A very important statistic to know about is the correlation coefficient. The correlation coefficient is used to describe the association or relationship between two or more variables.
An x and a y.
This is a picture of no correlation. The correlation coefficient is 0.00. Any x-score can be connected to any y-score. Now we have a small positive correlation, 0.30, between x and y, and you can see that there is some relationship between the score on x and the score on y. If the correlation goes up to 0.6, the amount of the relationship between x and y becomes stronger. And finally, with a correlation of 0.9, the association between x and y is quite strong.
So we've pictorially represented what the correlation coefficient looks like. How do you actually come up with a number that represents the correlation between two variables, x and y? In Chapter 5, we talk about the Pearson product moment correlation coefficient. It's a number simply that represents the correlation between two variables. The Pearson product moment correlation coefficient is determined based upon the sum of x, the sum of y, the sum of x squared, the sum of y squared, the number of observations, and the sum of x times y, or what's called the cross products. Typically, you do this with SPSS rather than calculate it by hand. But once you have this correlation coefficient, what's it mean and how do you interpret it?
First of all, notice that the correlation coefficient will always be between -1 and +1. Absolute value of the correlation talks about the strength of the relationship. A negative 0.6 is as strong as a positive 0.6.
The Pearson product moment correlation coefficient looks at the linear relationship between two variables. There may well be a curvilinear relationship between two variables, but that is not ascertained with the Pearson product moment correlation coefficient. We're looking at the linear relationship between two variables.
One way to help interpret the correlation coefficient is to calculate coefficient of determination, simply r squared.
We'll have more illustrations about that in just a second. And lastly, recall that if two things are correlated, you can predict one from the other, but there will always be some error in prediction called the standard error of estimate, the SEE, unless the correlation is perfect. Here's some illustrations of the coefficient determination and how you would interpret them. The coefficient determination represents the percent of shared variation, how much variation in the y variable can be accounted for by knowing the x variable. Here's a box that represents variance. Variance in some variable called y. Maybe it's achievement on a test. Maybe it's VO2 max. Maybe it's percent fat. But whatever it is, this box represents variance. If the correlation between x and y happens to be 0.9, then r squared, coefficient determination, is 0.81. So you are able to account for 81% of the variance in the y variable by knowing what the x variable is. And the remaining portion that's unaccounted for is termed error. Error will play a big role in many of the decisions that we make with statistical procedures. Notice in this case the correlation is 0.9, a very high correlation, yet there still remains considerable error.
If the correlation coefficient is 0.707, that squared is 0.5, and so the amount of variance that we can account for in the y variable, because we know the variance in the x variable, is 50%.
And the other 50% is error. What if the correlation is even less? What if the correlation is 0.5? If the correlation is 0.5, you square 0.5, you get 0.25. 25% of the variation in the y variable can be accounted for by knowing what the x variable is. The remaining 75% is error. This chart simply illustrates the fact that as the correlation between variables decreases, the amount of error of prediction increases. So you can use SPSS to calculate correlation coefficients, to calculate coefficients of determination in order to see if there's relationships between variables. We can also graph them as we've done here, or calculate the Pearson product moment correlation coefficient.